Hello everyone. So today we will do a video about quick commissioning of Sinamics drive. So the test setup today I have got is I have a G120 series drive. So the Sinamics drive has got two mod two modules. Like one is the power module. So this is the power module that I have, PM242, and this is the serial number. And the control unit. So this is the control unit CU240B 2DB. Okay, and I have a Profibus connection also. And the motor is this is the motor that we are connected to the drive. So we are having a 400 volt delta connected and 50 hertz 3 kilowatt and 1430 maximum RPM, and the ampere rating is 6.25. So we will commission this motor. Okay, so the software that we are going to use is Simulation Scout, and let's create a new project. Uh, okay, so the project is created. Now we are going to insert a single drive unit. So double click on this and select what is your control port. So I have, as I showed you, this is my CU240B 2TP, and this is the series 1PA1. So insert the same thing here, and select, first of all select what is your drive series. So my drive is Sinamics G120. Okay, you have so many like S120. So the one that I'm using is G120, and select the uh, same 240B 2DP. So 240B 2DP. Okay, and the version you can select the latest one. And if you have Profibus, I have Profibus, and also the Profibus address I have set. So in the on the device you have the option to select the Profibus address. So I have kept all these as 0, and the second and third one as 1, which means the address will be 2 raised to 1 plus 2 raised to 2, so it will be 6. Okay, so I'll keep the address as 6. So if you don't have Profibus, just don't do anything. Okay, so now I have inserted uh, G120 series CU240B 2DP as the control unit. Okay, so now next part will be to configure your PM, that is the power module, this one. Double click on this and select the power module. So here you have the option to give the serial number. So just see what is your serial number starting. So the same thing you need to select here. So this is my series. Okay, and now you need to go here and select your as per the name details. So I have 380 sorry 400 volt uh, input supply. Okay, so we can select, this is the series, and 5.5 kilowatt. Okay, so go to 400 volt supply, 380 to 400 volt and 5.5 kilowatt. So now let's see what is the serial number. So the serial number ends in 4ULO. Okay, So I will select 1B for you. Okay, I'll select this. Next, finish. Okay. So now uh, we will click on the configuration. Okay. So this is the right now what we have uh, configured. So this is the control unit, and this is the power module. Okay. So now let's click on the wizard. So this will be like a quick commissioning. So first select what kind of application you are using. So in my case, I am going to select the dynamic control. If you select standard drive control, the dynamic control will have a better performance, like the torque control, etc. Everything. So I'll select the dynamic control. So click next, and this one you can keep it as no change. If you are using Profibus for dataset changeover, you keep this, or you have different options like uh, the default one will be this. So I'll keep it as no change. And the motor I'll keep the same, and my supply is also 400 volt. And the motor that I'm going to use is an induction motor. Okay. And I'll if you have a standard Siemens motor, you can select this and select the motor from the list, but for my case I'm using a normal motor which is not Siemens, so I'll enter the motor data. So this is the motor. Sorry. So I'll enter this value. The rated current is 6.25, 6.25, and motor kilowatt is 3. Then rated speed is 1430. Okay, and input supply voltage 400, 50 hertz. There is no cooling type or anything, so I keep it 0. Then it is in delta connected. Oh, I have to change again. 6.25, 3 kilowatt, 1430, 400. Okay, click next, and the current limit. So current limit, my motor current is 6.25. I like to keep it to 150% of the motor current. So let's keep 9, and minimum speed was 0, and maximum speed the motor current motor maximum RPM is 1430. So it's okay. I'll keep it as maximum speed as 1500. If you want to run in rated speed, key change to 1430. And the only problem is when you cross the rated speed, your design torque will not be achieved. The ramp time, let's keep it at 5 seconds. Ramp down also 5 seconds. This again we can change this later. And the application. So I will use it for dynamic. Okay, so now this identification of the motor, that is the ID run. So right now we keep it as inhibited. We will later use it once you start the drive. Okay, so click next, and that's it. So the queue commissioning is done. So we click finish. Now how you are going to connect to the drive. So I'm using a USB communication. So you can set that in your PGPC interface. So anyway, I have already selected. So this is the mode of communication that I'm going to communicate with the drive. So click OK. Okay. So now you can see whether we can detect the drive here. So yeah, so my drive is detected. Okay. So I'll go online. Before that, I'll save this. So save. So I'll go online with the drive. So this is the G120 series. Okay. Click OK. So now I am going. Now I am online with the drive. So first I will download this setup into the drive. So you can click this. This is like after the download, whether you need to save to the permanent memory. So first we will download the basic setup, then we will do the ID run, then after that we will do this RAM to ROM. Okay, so let's download. So I'll post this video for some time because this is going to take a long time. Okay, so now it is downloaded to the drive. So now what I will do is I will switch on the three phase and we'll try to rotate the motor once. Okay, so I have switched on the three phase. Now we have the drive navigator just to see whether the uh, we can see here also how the parameters we have configured in the quick commissioning. We can see the same thing here. So this is where you give the speed set point. So if you have the Profibus connection, the set point will come from the Profibus. That part we will check later. And this is the limits, speed limit. So I have in the quick commissioning, I set this limit as 1500 RPM. If you want, you can change any value. Like let's say I need only, maybe I can keep it at 1600. So that will be your new limit. Okay. And this is your RAM generator. So if you want to change the RAM time, so I kept in the quick commissioning as 5. So again, this one you can change according to your wish. So I keep it at 5 itself. Okay. And your this is your speed controller. This is basically your PID, like this is the gain, this is the integral time. So I will keep default. If required, I can change it. And now we go to the uh, torque limitation. So basically the torque limitation depends on your current limit. Okay, so if you see, I have kept this value as 9 amps. 9 amps means it is 150% of the 150% of the normal current. Our nominal current is 6 amps, 6.2 amps. So 9 amps means it is 150%. So as you can see, the upper torque limit. Upper torque limit is 31.36 Newton meter. So this one either you can scale it here, or you can see that this 31.36 is calculated Newton meter. So this 31.36, the upper torque limit, depends on the current limit that you set here. So it means that there is an equation. The equation is this is the equation, like if your kilowatt, that is your power, and from the speed you can have the torque. Okay, so if you do this calculation, I will do the calculation. So 9.548 9.548 into power is 3 kilowatt divided by RPM, that is 1430 into 1000. So this is your torque for the nominal current, that is here 6 amps. So we can see what happens here. Like for example, if I keep the current limitation as 6 amps, your uh, torque limitation will be 18.94. Okay, sorry, 6.25 now. 6.25. Okay, see 20.03, this is the calculated value. So when I keep my motor in the nominal current, that is a motor rated current, the torque limit will be the maximum torque that can be achieved by the motor. Okay, so if I keep 9 amps, means it will be the again the 150 percentage of the motor current. So let's keep the same. So if I keep 9 amps, my torque limitation will be again changed. Now the torque limitation went to 31.36, which is the allowed torque limitation to go up to 31.36, because my current limitation is kept at 9 amps. Means my motor is allowed to go up to 9 amps, which means the motor torque allowed is up to 31.36. So I hope this was clear. Okay, so that defines your torque limitation. And finally we go to the motor. Okay, so once you start the motor, we can see this voltage, current, everything. Before doing this motor starting, we will do the motor identification. So if you can go to this commissioning. Okay, and we can enable this control panel. So it already have a warning like motor identification is not performed, so we will do that. So in the control panel, you click on assume control priority. This you can keep it our default, and you have to enable this one. Then you have this uh, on off switch to start the motor, stop the motor. So first we will just run the motor like say 500 rpm. Okay, and let's give a start command. Okay, my motor did not run because I have a brake. So let's configure the brake. So I have a relay output here. So let's open the brake when the drive is ready to start. Okay. Okay. So what I have done is I have put this ready. So whenever the drive gets a start command, it opens the brake and you can run the motor. So now I have configured this relay and I have connected this brake in this relay contact. So now let's see once more. So I'll enable this. My speed is kept at 500 rpm, and let's start. Okay, so you can see the motor is rotating, and it is rotating at 500 rpm. Let's stop this. Now we will do the ID run. Okay, so go to this identification, and you have a couple of measurements available: stationary, tuning, speed control. Let's do the stationary measurement first. So what happens during the stationary measurements is it calculates the motor resistance, including the cable, rotor resistance, then stator leakage, rotor leakage, and magnetizing inductance. So we will activate this measurement. So the measurement is activated means the next time I give a start command, it activates and measure this values. So you can see some default values here. This is the calculated value. Now when I press the start command, you can see the what is happening during the identification, and after the identification you can see this value is changing. So we will do that. Okay, so now the identification has started. So you can see what is happening during this time. And you can hear the magnetizing sound of the motor during this time. Okay, so the identification is done, and you can see the value changed here. Okay, so this is the measured value during the stationary measurement. So next we will do the tuning measurement. The tuning measurement, during this time the motor will rotate. Okay, so let's activate it. You can see this the warning here says that the measurement once active, you give the start command, it will do the measurement. So let's see. So I'll give the start command. So this time actually the motor started, and you can see what is happening. This will be a uh, short identification, and it depends on the size of the motor. So right now my tuning measurement is also done. So you can see the measured value here. So next will be the speed control optimization. Basically during this time what will happen is like your uh, motor will run when I activate this measurement, and it will also run in uh, different speed. Like it will give a uh, high speed, then low speed, then high speed. So all this happens during the speed control optimization. So I have activated this. So let's start. So now this running, stopping, running the motor. So you can see the way the gain, everything calculated here. Okay, these parameters gets calculated during the speed controller optimization. Okay, so all the measurements are done. We did the stationary, tuning, speed control. Okay, and if you want to see what happens during this what happens to the motor during the identification method, I'll show you that. So let's start with stationary again. So I'll activate this, and we'll see the motor again. So now it is going to do the stationary measurement. So what you can see is that the drive will give a small voltage, and it measures the resistance, inductance, everything. So you can see here, you can see this voltage, small voltage is applied to the motor, and with this small voltage the drive will calculate the resistance, everything. So we are redoing this measurement just to show you what happens in the motor when you do the stationary measurement. Okay, now let's see what happens during tuning measurement. Yeah, I'll do this tuning again. Okay, wait. Okay, so we'll see what happens during the tuning measurement. Rotates the motor. Okay, tuning measurement is done. Now let's see what happens in speed optimization. Okay, I'll activate. Okay, here you can see the speed going high, up and down. So whenever you do this, make sure your motor, everything is free to rotate. Okay, so that's it. All our measurements are done. Now we will just run the motor in full RPM and see everything works fine. Okay, motor achieves the full RPM. Okay, so now if you have the Profibus, you can go to the configuration and you can click on the interface, and here as you can, I already set this dip switch setting here. So I have put it as 6, means to this the second and third one is I have kept it on, which means the address is 6. So you can see the address here. Okay, and here you can select how you are going to communicate with the PLC. You can select the PZD type here, and I normally use the free telegram. Okay, I think this section I will do another video about this. So basically this is how you do a quick commissioning of the drive and to run the motor using Simulation Scout. So I think this was clear. So again, thank you for watching this video, and have a good day. Thank you.